Welcome back. I'll stop prevaricating, doing all sorts of other jobs. I'm finally going to get on with the time zone clock, which is very exciting. I've just finished putting together the remainder of the Nempnett Thrubwell kits that I couldn't finish last time because I hadn't got the clock movements that I obviously now have a nice suffice of. Also finished putting together the last of the Chronograph kits, that's right. And they're selling brilliantly. They're really popular. I'm so pleased. 3 Nempnett Thrubwells sent off this morning, this very morrow. So that's great. You always wonder a bit when you place an order for 100 clock movements, well 200, because there's 2 more trays of them, whether it's a disaster and that suddenly no one is going to want another Nempnett Thrubwell, but it doesn't look like that, which is very reassuring. I'm very pleased about that. So, dear friends, we've got the outside done. I'm not going to paint that, but I think I've decided to glue all this together and then paint it. Anyway, that's enough. Now on the back of this is the plastic insert which makes these clocks so good. I don't know whether Ikea still, I don't think they sell this particular version anymore, but I'm sure they sell other ones that are probably sort of sprung together with the same spring system with this internal support, which is really rigid plastic. It's very good. Now I've peeled off the original dial and now I'm cutting off these little flanges and bits and bobs off the back because I want this completely flat. And to do that, I don't know whether you're aware of these things, I wasn't for many years, but one of these vibrating saws. I won't put it on just yet. Basically they come with a range, you get all sorts of different blades for them, and the brilliant thing is, and I'm not aware of any other tool, a cutting tool that can do this, you can cut really hard up against an edge, a surface. There's no gap needed for anything, it's just flush, which is brilliant. So for things like chiselling out around tiles, chiselling out grouting, you can get particular abrasive cutters to do that. That's brilliant. I got this in fact after I'd finished the Barometric Prognosticator 1, that huge installation at the school, and realised that there was some plumbing to allow access to that. Once I'd installed it, I needed to cut a perfect hatch, and obviously using a jigsaw you're left with quite a wide hole gap, and you probably have to drill a hole first to get the blade through, whereas with this you just slowly plunge it in and you slide up, and it's fantastic. So I'm using this to cut that off, to cut a long story short. And voila, there you have it. Now I'm going to go and cut out the 3mm piece that I've got designed on the computer, that's going to mount the majority of exciting parts on. Here we have it. So this is 3mm acrylic. It's going to support the 2-stepper motors, and I'm also not wasting plastic. I'm cutting out the sensor holders for the stepper motors. So the switch, it's all worked. I've had to design it back to front, looking at it from the front. I've flipped it over now. That's where the Arduino Mega is going to go, etc, etc. The green lines, zoom in. Ages ago I worked out it's quite a good way with some components to actually use the acrylic to support wires. So you could solder things together, and some diodes and resistors and stuff on the surface of the board. And that worked really well. Right. Let's get this cut out. So what we've got, this is going on the back, like that. In fact, we've got the 2-stepper motors Mega. There's the Mega, by the way. Screw that on there. Now hopefully I've got everything to fit within the clock body, I hope. Anyway, what I'm going to do now, you can see that, what I'm going to do now is to, oh yeah, near the space for the 2, yeah, good. I'm going to cut out the engraving for the clock face, because what I now need to do is to make sure all these holes copy through. Here's the clock face engraving, and as always, I know I've mentioned it before, 3 different colours, 3 different types of cut. First one I'm going to do is the green, which is 70 at 15%, whatever, and it's probably worth mentioning, if I can actually find the thing, if I zoom in on one of these letters, you can see it's made of lots of small lines, 0.1 millimeters apart. So that just speeds up the engraving processes because here these really fine letters and that title there, they're really too small to do with lines. So that's been set on the engraving, the Raster engrave, where the laser goes backwards and forwards, scanning like old-fashioned television, switching on and off to give a really precise thing. And then finally cutting the L's. There's the map of America, the North America, with the hole for the flickering LEDs to indicate which time zone is the current one. There's the hole for the main hour dial, minute dial, AM, PM, and the clock illuminations and other bits and pieces. Lots and lots of holes, hopefully some of which are in the right place. I've decided to cut out some of the other remaining parts that I've got on the drawing, but I have absolutely no idea what they're for, what they do, or anything. But obviously they're necessary, or hopefully. I'm going to cut this lot out of 10mm acrylic, and this time I'm not hopefully going to be so stupid. I'm going to rely on the resting it on a piece of white cardboard trick, which works really well, stops it setting fire to the laser cutter hopefully, and produces a radius, as I mentioned before, on the underside of all the cuts, which is nice. I'm not going to video all of this, but just so you can see what it looks like with the card underneath. Really does work very well, because the alternative is to lift these 10mm acrylic probably 20 or 30mm up, so by the time the remains of the laser go through it and hits the inside of the laser cutter, they're out of focus sufficiently not to set fire to things. And here we have the first part. So there's the engraving, which looks absolutely lovely. I'm so pleased that once you clean it up with isopropyl alcohol, I also got rid of the rest of that tape. I couldn't bear to leave it on, even though I'd scraped most of it off, so horribly sticky stuff. So I'm going to have it this way up, that then sits in there, and these holes then line up for fixing screws for the LEDs, for these two as well. Talking of the, well, it wasn't, but I will, this bit here, there's the other, that's it, this piece, and that's going to sit over there, and you can see how it lines up with the minute dial in the middle, and then the AM and PM indicators down here. Now, ages ago I worked out how to do these to make them look really nice, because you could have something boring, but why do that when you can get these LED lamp lenses? I bought dozens of them years ago now. They're made of plastic. They've got a ridge around the edge and a huge, or very small, I think very small focal length, that's right. So if you engrave the right size hole in something, they just push in like that. The lip just sits around the outside, and then you stick them in simply, as I've said before on numerous occasions, by not having to do it particularly messy. Just put a few little drops around the back, and you'll probably see that the glue has been soaked in. Do another one around here. Anything to watch out for is that it doesn't sputter when you're squeezing the tube. You don't get a little bubble of superglue that suddenly spits onto the surface of the lens. So that is now perfectly stuck. I'll do the other one. Welcome back, another day, another dollar. This is now dry, obviously set, and they just look so lovely. just adds something very nice. And that underneath is, if you look through them, you'll just see white, because the flickering LEDs are going to shine onto the back of this, which I did some experiments ages ago and found it worked really well. This bit's quite interesting. It's 2mm thick, opaque white. And all these little holes are in order to allow me to unsolder some. Hang on a minute, I'll show you. Well, here's an end that disappears into the drawer of mystery. Unsolder these warm white surface mount LEDs, because I discovered ages ago when I was developing this whole clock that the best way to illuminate it was with these, having tried all sorts of other LEDs. So I'm going to create a little network of wires on this that I can solder the end, or solder these into. I will come on to that later, but it works really well with 6 of them around. It just gives a beautiful glow that's powerful enough to illuminate everything. So that's that and that. Now I've started putting bits on here, as you can see, I think more than yesterday. Oh, there's also, I started putting the components on. Just a convenient way. Just do some sort of strange zooming effect. There's some diodes, which I found helped the Arduino to run an AM and PM LED with a 220 ohm resistor wired up, so that if this is high, one will come on, if it's low, the other one will come on, because the other side of each of these is connected to positive and 0 volts, plus 5 and 0 volts. So it saves having 2 outputs. You can just run this with 1 output, because you know that one of these 2 LEDs, AM and PM, is always going to be on. There's the read switch, I didn't say read relay, and then a ground wire and some more bits and pieces for the top 4 LED time zone LEDs. And then on the other side you can now get a better idea of what no, you can't, we're taking it to pieces again. This has got the read switch, because that's the minute hand, so it needs some way of calibrating itself with the Arduino, or vice versa. And this one is the hour, so that, well, there it is. It's only going to have to go around to there and then back. The way I'm going to keep it synchronised, in case it doesn't quite line up sometimes or drifts off for some reason, because I haven't quite got the gearing right, is that every time some function in the code, the Arduino sketch says, okay, it's 12 o'clock, point to 12 o'clock, it's not going to say, okay, add another how many degrees. It's going to say, okay, keep moving until this micro switch switches on. So that means, and then that'll click that. That means that it will remain accurate. Every 12 hours it'll be recalibrated, in effect. A cunning plan. Then I started thinking about how to fix all this together, because obviously it's multi-layers. You've got the clock engraved bit, then you've got this plastic bit, you've got that on the front, then you've got this on the back. And if you think about how to line up LEDs and wires and motors and clock hands and things, it all gets a little bit catch-22, in as much as once you've screwed some of these bits on, you cannot, because originally this was on the front, so once that was screwed on, you couldn't any longer adjust the position of the hour hand, which I think is really important. I remember it was quite frustrating, and that's because I was using these spacers that I'd cut on the laser cutter, 12mm diameter with an 3mm, 3.5mm hole through it, just as spacers, so that everything is spaced 10mm apart. That's 10mm behind that, that's 10mm in front of that. And I suddenly thought, having glued them all on in a fit of pique, why on earth not have these tapped? If they're tapped M3, it means that I can have, say, 10mm long brass screws holding this together onto that. It also means that this can then screw onto something else. I'm not quite sure about that, actually. I'll have a think. Yes, I'm not sure about that. I haven't quite got the plan sorted out yet, but I started off by thinking, yeah, I've got some of this 12mm diameter acrylic rod, but then I tried it on the lathe and it was all melting, the drill bit was melting it and trying to get 10mm accuracy set up. So I think then I tried cutting it on the bandsaw, but it was really rough finish and not quite right either. So I finally returned to the laser cutter. Now, with an M3 tapped hole, the eel in the middle needs to be 2.5 millimeters, the blank. And if you've seen a previous video, I was about to say, it means that I can then use this lovely drill tap combo. But I've just realised that this is M4 and I haven't got one of these in M3. Never mind. Into the moment of truth. Let's see what we've ended up with. And whether all this time I've been getting far too big for my boots. I would say I've been getting far too big for my boots. There's a little bit of ovality, if that's a real word there, but not much, not nearly as bad as it has been. Ah, how fascinating. So, don't be too clever. Because when I'd first got the laser cutter, I didn't have all these wonderful ideas, so just put things on and it cut them perfectly, and it has cut these perfectly. Well, live and learn, dear friends, live and learn. Stop being clever and just do single cuts, because then the acrylic is heated up once and cooled down once and doesn't have to go through all sorts of cooling and distorting cycles. Fascinating. Right, I'll get these tapped. Right, now I've got my tap, M3 tapped there. That goes round and round, but not very, actually that's on number 2. I think I'll put that on 1. This is so fine that it melts acrylic very easily, hence the fact I'm going to dip it in some isopropyl alcohol as a cooling agent and lubricant, and then single-handedly, there we are, get the middle out. That came out much more easily than normal. And then the only thing with this is I've got to get it, that's right. As always, clear your flutes, as my mother used to say. And I think, to err on the side of caution, I'm going to dip it back in to make sure, because I know from experience, too much working too quickly and it just ends up melting everything. Right, that's good. It's got the floof out the end. It's making a rather strange noise. Right. Well, I'm very pleased with that. That has tapped really nicely, and I've learnt how to cut these out really well. 10mm acrylic. Fantastic. It's a good day already. I'll get the other 5 of these made up. Right, on to making the Illuminator. It also acts as a diffuser, I think I mentioned it, yeah, for the AM and PM thing, and also illuminates the minute dial as well, which is lucky. And I think I'm figuring it out, because I did engrave on one side a few very, very vague instructions. I've fed some wire through these holes, sort of stitched it through, because I think these were cut out the right size for the little surface mount LEDs, and vice versa on the back. Here's a strip. They're warm white. I've just connected these up to 12 volts. Let's see what happens. Oh, that's interesting. These ones don't actually work at this end. I've got absolutely no idea why. That's strange. Anyway, these ones work, and they produce a lovely warm white. It's a much more yellow in it. Cold white I've tried, and it just does not look right. It's particularly in steampunk machines. It needs to be warm. I suppose reminiscent of incandescent lamps, flames, gas lights, all that sort of thing, which are always very warm. So what I'm going to do is to unsolder, how many of them? 1, 2, 3, 4, 5, 6. 6 of them. I know you can buy them separately, but there are so many varieties and sizes and this and that and the other. I just don't know where to start. So in the end I've always just gone with the slowly using all these ones up off this one roll of warm white. Each block of 3, there's 1 resistor and then the 3 LEDs. These are 12 volts, so each you need far less resistance basically, because 1 resistor reduces it sufficiently for the remaining whatever voltage to run the remaining 3 things. So you just cut them off. You can cut them wherever you want and solder 2 wires to connect them up. They are so amazing. Having grown up with well, primarily people's second-hand thrown away not working fairy Christmas tree lights from Christmas, and having to make all my inventions using those. This is just such an amazing joy. LEDs are LEDs are just incredible, absolutely amazing things. When you think that the incandescent lights used to turn 90% of the energy into heat and 10% into light, so they're basically heaters that coincidentally produced a bit of light. That's amazing. I mean, that's the technology they had at the time, whereas these amazing little things, I think it's the other way around. 90% into light and possibly less than 10% into heat. Absolutely fabulous, especially if I get the shots nicely centered and arrange them dramatically. Ooh. Right, now I'm going to try and fit them into here. I won't bore you with me wiring all these up individually, but just one thing. Which way round they're connected, and the word fails me, is indicated by one corner having a little, there we are, perhaps you can see it. It's got a little rebate in one corner, and I can't remember which that signifies, but thankfully I remember engraved in here, if I catch the light somehow, I've put a little engraved triangle there, there and there. So the other ones are going to be the other way up. So there's the little triangle, there's that, and then that just slots into there. Obviously a lot of experimentation occurred to get this to fit, push fit just like that. And the connections for each of these, now I've started talking, I might as well carry on, are along either side. There's a piece you can solder to there and there, conductor either side. So that means, now I've got this here, I can focus, just solder that onto there, and that'll hold that in place. Excellent. Right, I'll get on and do that and get back to you once it's done. Right, I've got them all soldered on, and I've got these wires soldered on and the other bits. I'm going to start off by connecting that to ground, and I've got plus 5 volts connected to a 220 ohm resistor. Aha! There's 1, 2, 3, 4, 5. Brilliant! So they all work. So common ground then, common 0 volts. That's really good. I'm very pleased about that. I'm having a separate resistor on each of these because 5 volts I don't think is even enough to run 2 of these LEDs, because they need to have a certain amount of voltage available, if you like, across them for them to be able to work, and I don't think there's enough with 5 volts for 2 of them. As if you remember back to these, they've got, or did have, 3 of these running off 12 volts and a small resistor, so I think that's why I'm having a separate resistor 220 ohm for each one, because then the 5 volts will be quite ample. And just coincidentally, thought I'd mention it, obviously you can't run this if each LED is drawing about 15 to 20 milliamps. That's going to be far too much times 6 to run from an Arduino output, which is a maximum of 20 milliamps, sourcing or sinking, but an absolute maximum of 20 milliamps, otherwise you'll damage it. So you can't do that. But the great thing about these interfaces for the stepper motors is these chips actually have 7 interface circuits in, and only 4 are used for each stepper motor. And they're just, the other 3 inputs are 3 of these pins this side, and the other 3 outputs are 3 of these pins that side. Great! You don't need LEDs and things for that. So what I've done with lots of the machines, when I've needed to switch something, is I think these can switch half an amp or something. It's quite a lot, 500 milliamps I think. I just use up a couple of these extra interface circuits, which is great because it saves you from having to have any other sorts of interface circuit, basically, to coin a phrase. Oh, and I've also stuck on these tapped spacers here, so that's good. So they're all stuck on. Great stuff. Right, I will now consider getting all this fixed together. and see what happens then. Actually, I need to screw the Mega, Arduino Mega down first before I do anything else. The other great thing about using these threaded spacers is that one of them came up underneath where the Mega was going to go, which meant I'd have to, again, catch-22, that would have to go on. Then I'd have to screw the Mega down, but I couldn't get underneath because it was screwed on for the bolts, nuts rather, whereas just having a threaded thing, it just makes life so much easier. Let's get on with that. I do sometimes have good ideas as well. I was thinking, right, to this bit, which forms the back of the minute hand dial, how on earth can I line that up and get it right in the middle, and what's this all about? And what turns out that I rather cunningly made it so that once these lenses are glued in with the little raised section, if I rest that up against it, it's centred perfectly. How thrilling! And then I'll stick this down in the same way by dripping some drips of glue on from this side so it doesn't show on the other. Cool. Right, dear friends, as I'm about to start assembling this, what I realised originally is that it looks much nicer if the brass carries on from all around the outside, then you get the glass, and then the brass goes around whatever this part's called, rather than having black plastic. What I did find though was then if I painted it with the little rebate painted as well, when I put the glass, circular glass thing, oh, my mind's failing me today, window, is it? The circular glass window in, it would scratch little bits of paint off around this little rebate, which could then regularly fall in, and just you get the whole thing together. Really pleased, and then you look at it and find there are a load of little flakes of paint. So I've used a bit of this engraving laminate, just cut, that I've pushed into there. I've hoovered it. So let's do some painting. Right, I'll leave that for about 10 minutes and then come back and do another cut. I don't care about the middle of it because obviously that's going to be covered with the engraved clock to face thing. Oh, words fail me. Thanks very much for watching. As you can see, I've now, in the next video, started attaching lots of lovely coloured wires to everything. How exciting. And there's also the no stop, that's for the next video. Thanks again. Do remember to subscribe if you're interested in this sort of thing, and remember, I'm always happy to answer any questions or queries you have in the comments. Thanks very much.